let's start the sessions. I'm going to complete as many as I can within 1.5 hours. So I have cover up very special technical criteria related with the house construction, mainly the resilient housing construction, and also some experience I have gained during construction of Canterbury Residencies project. So this will be a very vital presentation to you all, since you all guys are involved with this kind of construction works. So not only the house construction works for any housing, any construction type, this will be very important to you all to have a wide knowledge about construction activities, starting from structural works and the finishers works. Okay. According to the presentation proceedings, I will start. Okay, I will continue. Now, the thing is, now this is the content actually I'm just going to cover up. Okay, the first one is vulnerability to a hazard and degree of damage. Okay, basically, I'm covering up the natural hazards and also some other hazardous conditions like ground conditions, expansive soil conditions, and some kind of ground subsidence conditions. And also, I'm just going to guide you how to gather information and how to follow through with the hazards maps. Okay, so that is that part, and the second part is requirements for a resilient house. So in this session, actually, I mean cover up the specifications and what are the weaknesses of a non-engineered house. So actually, you can identify what are the things you need to omit when you are doing the construction of non-engineered house, resilient house. So the second thing is basic components and structure of a hazard resilient house. So as I mentioned earlier, the weaknesses and the positive sides of the house construction works I will cover up in this session. Okay, the third session is the planning phase of a resilient house, which is very important phase. So there are several phases in terms of the construction. So the planning phase is a very important phase when it's come for the construction. So how to select the land for that one, and also the planning clearance and the other approvals, how to obtain all those things, and what are the authorities to get the approvals, and also the layout and orientation, how to select the orientation of the house, and how to select the direct the coordinates and the layouts of the house or any other construction work, and also the earth retaining, which is very vital, important work in terms of the land development works. So earth retaining works, I will cover up entire everything. And the fourth session, the design and construction phase. The first one is building materials, how to select the building materials, and what are the criteria you need to adopt when you are selecting the building materials, and what are the approved materials in terms of the quality and cost. So many things related with the building materials and the foundation systems, starting from the deep foundation and shallow foundations, and what are the nature of ground, about the earth stabilization criterias, and subsoil profile, bearing stratum, and determination of bearing capacities, and also the selection of the foundation type, so on. And also the superstructure. So once you cover up the foundation system, that is the substructure, so you need to move on to the superstructural works. So under the superstructure works, I will cover up floor and roof beams, cement block and brick walls, and what are the stiffener columns and stiffener beams, and what are the purposes of those elements, and the lintels and sill beams, and also the roof and rainwater accessories installation, which is a very vital components in terms of the roof related activities. So actually, that is the things I am going to cover up, and also I will just going through what are the experience I have gained throughout the construction period of Canterbury Residencies project, and what are the challenges I have faced from the starting up to the successful completion of the project to 254 houses within under 2 years period. Okay. Okay, starting from the first session, the vulnerability to hazard and degree of damage. Okay, so the when you are talking about the natural hazards, actually you all know what are these things I'm going to talk about. Okay, actually, some of these natural hazards are available uh, under these Asian stratum, but most of the natural hazards related with some kind of other countries, other regions. So actually, I'm just going through rapidly about these background informations. The landslide, all you know about the landslides, what are the impacts and what are the outcome of the landslide, and the floods you all know, and the very typical and very familiar natural hazards for the Asian countries and also the Sri Lanka region. And the tsunami, or we have faced tsunami in 2004, and you know what is the extent and what is the impact we have faced in those period. And high wind cyclone, as I mentioned earlier, some of these hazards actually not much familiar, not much not much familiar with the Asian regions. And earthquakes, nowadays, now Asian countries also facing the earthquakes, mostly on China and Japan. And some ground subsidence, so ground subsidence also now it's become familiar in Asian regions mostly. So that is that. Okay, other so apart from these very well known, very important, very familiarized natural hazards, actually you have so many practical experience regarding the other hazardous conditions, not the natural hazards, some other hazardous condition like ground condition. That means normally we are normally telling these things as soft and loose ground conditions. So as you can see in this image, you can understand what is this all about. Okay, so this is all about the ground conditions and the ground subsidiary soil profiles. So depending on the soil profile, so there will be so many impacts for the structure on top of the soil profile. So this is actually the condition with subsoils not having adequate strength. So that means these soil conditions having not have the adequate bearing capacities, soil bearing capacities. Okay, so the other hand, these soil profiles are associated with loose deposits of silt and fine sand, and it's highly compressible peats and soft clays, which are often found in low-living areas, paddy fields, marshlands. Actually, we have the experience in Canterbury Villas project. We have some houses near to the paddy fields, and we have now actually you can't see the outcome because we have constructed already all those houses. But before construction of all these houses, we have done this ground improvement. So so many activities we have to do this ground improvement. And also if you meet this kind of subsoil condition, that means soft or loose ground condition, definitely it can settle. That means the structure on top of the ground condition can be settled, and also there will be some deformation in the structural elements. That means, for example, if you construct the structure on top of this soft or loose ground condition, definitely with the time goes on, the structure may be collapsed. Collapse means there will be some settlements. That means you can see some structural cracks along with these structural components, walls. That means definitely your subsoil condition is very weak. That means there will be some soft or loose ground conditions. And also there are some other reasons for this kind of impacts, maybe some kind of buried ducts or water pipelines. So that means the ancient times there will be some buried ducts or water pipelines are coming, so no one will notice all those things. Then what you are doing is you are just constructing houses or any structural components on top of that one before getting some uh, proper investigation, what will happen? There will be some buried ducts. That means internal cavities inside. So what will happen with the time goes on with for the loading on top of the subsoil condition, because of the loading, this will be collapsed. So that is the actual scenario of these collisions. So that is that, and also there are some dislocations, and also the structure cannot be functional due to these issues. So that is the main things if you undergo soft or loose ground conditions. Okay. So the next one is the expansive soil conditions. So what is expansive soil? So expansive soil actually have a wide range of conditions. The soils that undergo significant volume changes. That means if there is a volume change in the soil profile, there will be a volume change in the soil profile due to the moisture content. Okay, due to the moisture content, that means due to the moisture fluctuations, there will be a volume changes inside the soil. So that soil is an expansive soil. So if you notice that kind of expansive soil, what will happen? There will be sagging of brick lines. Can you see these images? There are so many cracks in the walls, and also if you have an opening, you can have so many diagonal cracks. Okay, so these are the significant significant things if you have expansive soils underneath your structure. And also uh, cracks and separation at wall corners can be happen, as you can see in these images. And also, as I mentioned earlier, there will be some cracks above the doors or the sill levels. And also there will be some warped doors or windows frames. That means the when you fix the door frames and all these window frames, definitely there will be some warping on these indoor frames because your structure is going to settle. So that is that. And also you can see some pavement cracks. If you observe some pavement cracks in your structure, that means under the structure there will be definitely expansive soil profile. Okay, so there are two types. One is soft or loose ground conditions. The second one is expansive soil conditions. So that is the main hazardous conditions. Okay, the other one. So this is a main and very impactful issue compared to the other issues. So this is ground subsidence conditions. Normally we are calling as ground subsidence. Okay, this is actually the settling or sudden sinking of earth surfaces due to subsurface movement of earth materials. That means due to that is also the reason of the large volume changes. Okay, that means if you have a tunnel, ancient tunnels underneath the soil profile. Let's say you have some kind of mining activities underneath the soil profile. Mainly in Ratnapura, Palmadulla district, there are so many mining activities undergo. So if you construct a house or any structure on top of that kind of areas, definitely you need to have a soil investigation. Definitely you need to have a borehole, and you need to check the profiles, borehole details, and you need to do a proper soil investigation before carry out the structure. So you need to identify all these ground subsidence conditions. Otherwise, what will happen? Definitely, your structure will be sink. Okay, there will be no any cracks identifications. Definitely, structure will be dislocated from the other structures, and you can see these images how the impact of those things. So there will be no any reconstruction. Definitely, the collusion is there. There will be some fatals, not the injuries. There will be definitely some fatals. Okay, you can't actually rectify all these houses. Definitely you need to evacuate from the location. So that is that. So I have explained three conditions, three hazardous conditions. One is soft or loose ground conditions, the second one is expansive soil condition, and the third one is ground subsidence condition. Hope you all can understand all these three hazardous conditions. Okay. Okay, now I'm just talking about the hazards maps. Okay, there are certain variations, and also there are some uh, important hazards maps. Not only Sri Lanka, not only Asian regions, in the worldwide, definitely there will be some hazards maps. There are different types of hazards maps. Okay. Now, in this image, you can see a landslide hazard zonation maps. Okay. That means if you're going to construct a house or any other structure in any district or any region, definitely first of all you have to use the hazards map. And also, what you have to do is you need to observe what are the safe slopes and also the what are the landslide not likely to occur areas. That means in the return period of 10 years, maybe 100 years, maybe 500 years, maybe 1000 years, but for the 1000 years, 500 years, maybe for the 100 years, there will be no data to build up this kind of hazards map. But for 10 to 50 years, we can actually build up this hazards map with the data we have. So what we have to do is with those data, we can actually build up this hazards map. Actually, there is a portal for that one. Actually, you might undergo in your university times GIS, okay, graphical information system. Using graphical information system software, you can actually develop this kind of hazards map with your own data. Okay, so now this landslide hazard zonation map means you can actually identify what are the areas having river or reservoir and major road streams, and also safe slopes and landslides not likely to occur areas, and also modest level of landslide hazards. Okay, so this kind of variety of hazardous areas you can actually understand. Every region there is a, that means for a actually this map I have extracted from NBRO website. You can all you can you all can actually go to the website and download these kind of maps. So under this risk management division in NBRO, they have several hazards maps, especially for the these 10 districts. That means most prone areas for these hazards, landslide hazards. So that is that. As you can see in this image, uh, as I explained earlier, landslide hazards, this is for the floods hazards. Okay, so this is very straightforward. I'm not I don't I think I don't need to more explanation. Definitely you straightforward, you can understand what are these all about. So there are they have mentioned high risk areas and the low risk areas, moderate risk areas, and the no risk areas. So actually, you can understand what are the areas, uh, most riskful areas for the construction works, and what are the low risk areas for the construction works. So easily you can select when you are going to select a land. Okay, that is that. And the most important thing, when it's come for the high rise buildings and the mid rise building, definitely you need to actually consider the lateral forces. Okay, so most important lateral force is what? That is wind loading. So this is for the map of wind loading. Actually we have divided up to three zones. Okay, as you can see in this image, there are three zones easily you can identify. So according to these three zones, the wind speeds are defined for each and every zones. So when you are going to design a structural high-rise building or mid-rise building, definitely you need to take these values, take these wind speed values into account when you are doing this calculations for the design structure. Okay, so that is that. So I have explained you three maps. One is the first one is the landslide hazard zonation maps. The second one is flood hazard map, and the third one is wind loading map. Okay. Okay. Let me check the waiting room if there are anyone. Yes, one is there. Okay. I will continue again. The second heading of the today's session, requirements for a resilient house. Okay, resilient means very safe house. Okay, it's a very small explanation for the resilient. Okay, now can you see this image? I think hope you can see all in this image. This is actually a non-engineered house. This is actually a non-engineered house. Non-engineered house means the house has constructed without considering any structural criteria. They are not actually considering the locations during the planning phase. They are not much considering about the subsoil conditions. They are not much doing this soil investigation and all. They are just constructing using the gamebas. Okay, when it's come for this non-engineered house, there are so many significance. That means significant points you can understand, you can identify. Okay, so I will go one by one according to this list. You can see in this list, I will go through that one. The first one is inadequate depth of foundation and floor located below floor level. Okay, that means if you construct a house in a slopy mountain range, okay, slopy mountain range, there will be some streams underneath the soil profile. So what will happen? As I explain you, there will be a volume change. So what will happen? That soil profile becomes expansive soil. Okay. So I'm just directly applying the what I have explained earlier. Okay. So try to understand. So what will happen? There will be some expansive soil underneath. Very straightforward. Definitely there will be some cracks like this. Okay, there are so many issues I have mentioned in these numbers. Now this number one, inadequate depth. That means they are not actually embedding the foundation into the soil. That means I'm always telling in this site construction people, you need to follow 2 feet. That means 600 millimeters as your minimum embedment depth. Otherwise, what will happen if you violate that norm? What will happen is there will be inadequate depth foundation. Okay, there will be some overturning of the foundation due to the subsoil conditions. So definitely keep that in mind. There should be a adequate depth for the foundation. That is a very important criteria. Okay, the second one, inadequate connections between walls and lack of frame structure to increase the stiffness. Actually, when it's come for the structural design, we actually explain in this one this frame structures and all properly. But I'm not going to explain to that much that extent. But here the normal very simple idea is you need to have a better connections in between your structural elements. Okay, number two. Number two, you can see these things. If you don't have a proper connection in between your walls and your foundation, what will happen? There will be some slides. Okay, there are some expansive soils. There will be some earthquakes inside. Your foundation is somewhere there. Your wall is going somewhere there because there is no any connections. So there will be some cracks. And the third one, unstoppable, unsupported gable wall and perimeter wall. Okay, that means some of the walls are not supported. That means some of the walls not interlocked with each other. Use the correct term every time. Some of the walls, that means internal walls, are not interlocked with each wall. So what will happen? There will be some, again, there will be no connections in between these internal walls. And also, if your wall height is very high, if the area of the wall is exceeding 9 meters square, not that in somewhere, if your wall size is 9 meters squared, and if the wall size is wall area, I'm just telling the if your wall area is excessive, more than 9 meters squared, definitely you need to provide some stiffness structures. Otherwise your stiffness will be not adequate to bear his own weight. Okay, so that is that. ඒ කියන්නේ අපි එක wall එකක් ගත්තොත් එහෙම හැමතිස්සෙම මතක තියාගන්න 9 meter squared. ඒ කියන්නේ වර්ග මීටර 9 හැමතිස්සෙම මතක තියාගන්න. වර්ග මීටර 9ට වඩා වැඩි වුණොත් එහෙම wall එක digging හෝ උසින් අපි දෙමු digging වැඩි වුණා කියලා. digging වැඩි වුණොත් එහෙම අනිවාර්යෙන් ඔයාලට එතනට දාන්න වෙනවා stiffener column එක. මම හැමතිස්සෙම කියන්නේ stiffener columns මෙයා දාන්න මෙතනට දාන්න කියලා. එතකොට පලින් වැඩි වුණොත්තේම අනිවාර්යම 9 m² වයිලේට් වෙනවා නම් අනිවාර්යෙන් එතන අතර මැදට දාන්න ඕනේ ස්ටිෆ්න කොලම් එක. හරි අපි හිතමු ඕක උසින් වැඩි වුණා කියලා. උසින් වැඩි වුණොත් එහෙනම් මොකද කරන්නේ? උසින් වැඩි වුණා කියන්නේ තේත් 9 m² වයිලේට් වෙනවනේ. එතකොට ඔයාලට ස්ටිෆ්න කොලම් එකක් දාන්න බෑ. ඒ කියන්නේ vertical element එකකින් ඒක separate කරන එක තේරුමක් නෑ. එතකොට ඔයා දාන්න ඕනේ ස්ටිෆ්න beam එක. That means horizontal beam along the wall. So definitely the area will be divided. So your 9 m² will be coming up. So that is how you need to increase your stiffness in the walls. Okay, so that is that for the now here number 3, unsupported gable wall and perimeter wall. Unsupported means if there is no any uh, stiffness beam in between the wall region, because your gable wall is very high. You just apply with the villas construction. Okay, you have 10 feet signature villas, 8 feet signature villas, which is having this signature type wall, and you have this gable height wall. What you have to do, definitely you need to provide a stiffener beam in the middle section of the wall. Otherwise what will happen, your wall weight, the dead weight of this self weight of this wall, he can't bear itself. Definitely it will be a reason for the cracks formation of that particular wall. Okay. Number 4, diagonal cracks at corners of opening due to not providing of sill and lintel beams. Always I'm telling, and I'm doing the inspection related with this thing. Definitely you need to have a lintels that is for actually bearing up the upper for portion on top of the window or door. But for the sill beams are for the avoiding the diagonal cracks forming in the diagonal side of the window opening. Okay, so definitely you need to have a sill beam and the lintel beams. And the number 5, can you see number 4? You can see in this image also there are some diagonal cracks formation. Okay, these are the diagonal cracks. Actually, if you go to your villages and all, you can if you observe these normal houses, definitely these houses the people are don't provide these sill beams. Go and check, definitely there will be some cracks like this. Okay, so that is that. And the next one is inadequate connections of roof framing of structure. So that means now I'm coming to this thing later on, the components of the roof structure. So there are some components: wall plates, ridge boards, and rafters, purlins. And if you construct in exposed rafter roofing, definitely there will be some eye panels or ceiling sheets. So and also zinc column roofing sheets and all. So there will be some proper connections into the walls. Otherwise, what will happen? Just for example, using the Bernoulli, if there is a cyclone inside, your roof structure will be going away. So there will be adequate connection to the existing structure for the roof structure. So we are actually using anchors to the wall. If you closely monitor the roof construction works, you can see how we are fixing these wall plates into the wall, and how we are fixing these ridge boards and all, and what is the lapping in between the connections, and what are the rafters spacings and all, and what is this purlins and all those things. Actually you can have a clear idea when you are observing closely. Okay, so that is that. Actually definitely you need to have a proper anchoring details for the roof structure. And also the 7, inadequate anchoring of door and window frames to the structure. So definitely you need to have a proper anchoring system to the structure. That is why we are actually door frames we are actually fixing using these anchors. Okay, not only using hole fasteners, we are using anchors to fix to the structure. Okay, that is that. And inadequate connection of gable to structure and roof into gable, that is actually I have repeated in last time. And then number 9, inadequate anchoring of roof sheets and or tiles to roof framing. So definitely that is actually an your roof structure should anchored properly to the walls, and also your roofing sheets also anchored properly to the your roof structure. Okay, otherwise the same collision will be happen if there is any very high wind areas or cyclones happen. So that is that, and also the disturbances to the existing ground condition. So that is actually very popular issue in terms of these mountain areas. If you construct houses, definitely the existing ground condition you need to adapt. Okay, if you have a residual soil means if you have a very loose soil profile, very loose soil stratum, definitely there is a pond for the collusion. So you can't construct a house nearby that kind of areas. So disturbance to existing ground condition is very vital fact when it comes for this construction. And number 11, possible damages to neighboring structures. So you can construct your own house, but you can't obstruct your neighboring houses or any structure. Okay, and also the other hand, in the other way around, you need to consider the other structural if impacts to your house if you construct that your own structure nearby other structures. So definitely you need to construct the house considering both ways. Okay, so that is that. So I hope you can understand about these weaknesses of non-engineered house. Okay. Okay. Now these are the basic components and structure of a hazard resilient house. That means hazard free houses. If you want to construct a hazard free house, so these are the basic components you need to adopt. Okay. Now the opposite sides of the other things. So I'm just rapidly go through this thing without explaining much. First one is increased depth of foundation and raised floor levels. So that is actually I have explained you. Now see this image and compare with this previous image. There is no any embedment depth in the foundation. You can see this number one. Now here this number one, you can see this ground embedment of this area from the existing ground level. So what is the depth? There is a sufficient depth, adequate depth provided for this foundation. Number one, and the frame structure with reinforced concrete columns. Okay, you can see this frame structure. There are some columns, there are some beams, and there are some lintels and all. There is a frame structure. But here, there is no any frames, just the walls. There are so many village type houses. They are using these bricks and all without constructing the columns and all. They are just constructing the house. Okay, but this is the correct way. There should be some structural elements like columns and beams to transfer your loadings. Even for a single story house, definitely your self weight is there. Even there is no any slabs or any structural weights, but if you construct a wall, there is a self weight for that one. So definitely you need to bear the self weight and transfer this load into the foundation. Keep that in mind. Okay, so that is that. The next one is wall stiffened at openings using lintel and sill beams. I have explained that one. Lintels and sill beams you need to definitely provide. The next one, good quality building materials used in all components to meet required strength and other properties. Definitely, you need to adopt all these construction positive practices, but definitely you need to use quality materials. Otherwise, what will happen due to these low quality materials, your structure will be collapsed. That is that. And also door and window frames properly anchored to the structure. Now here you can see the anchored elements. These door frames are not anchored directly to the wall. It's anchored to the stiffener columns and also some lintels and also the tie beams, the anchored. And number 7, roof structure properly built and connected to the main structure. Here you can see this structural things. Now in this image actually you can't actually have a clear idea how it's connected to the structure, but I will explain later. The number 8, properly connected gable walls and structure and roof into gable wall. Now here the gable wall means you can see this triangular type your wall. On top of this triangular type, you can have a cap-in beam. If you have a featured wall, featured roof structure. We are just constructing angle beams. On top of that kind of structural elements only, we are keeping the roof structure. Okay, that is that. And roof covering properly connected to roof structure. So you can see under 9, it's actually covered using proper tile elements. That means not a very wide area, one material. It's actually divided. You can have see this grid. Okay, so if you provide the grid type uh, covering to this roofing, definitely the firm stiffness will be developed. Okay, the number 10, minimal disturbance to ground and supported cuts and retain slopes. Okay, now just compare with this image number 10. You can see these ground disturbances. There are some steep slopes and all, and also there are some lands. Okay, and so there will be some so many retained structures. That means retained soil profile to be retained. So these soil profile definitely you need to retain. Otherwise, there will be negative impacts to this structure if you can't retain this structure. Now here, see the difference. Now he has provide this retaining wall here, and you can actually worry about this soil profile. So there will be a retaining wall. So there will be no any collusion to this house or any impact. So that is actually very important criteria when it come for the construction works. Okay, now the third session, planning phase of a resilient house. Okay, so this is also very important in terms of house construction or any other construction activity. Selection of land is very important and very time consuming work. Okay, okay, I will go through one by one, land and location. Okay, now definitely, if you consider one kind of land area, there will be a legal right to the owner. Definitely, without a legal right, you can't actually own an area. Okay, so it must be ascertained whether residential buildings are permitted in the land. That means you need to uh, search. You need to have a proper permission whether you can construct a residential building or any other commercial building in that particular land. So there will be certain uh, areas the government will not give you a permissions to build up your residential or commercial houses. There will be some issues with the government regulations and all. So many other criterias. They are not much care about your land. So that is why some of the lands we can do the construction activities. And the second one, the topography. The topography is a very important thing again. That is actually if you have elevation or slope, undulations or drainage or ground conditions. That means if you consider the topography of a land, that means අපි කියනවා ඒකට පිහිටි ආකාරය. පිහිටි පොළව කියලා කියනවා topography. එතකොට මේ topography එක ගත්තොත් එහෙම පිහිටි පොළව ගත්තොත් එහෙම එක elevations තියෙන්න පුළුවන්. slope තියෙන්න පුළුවන්. ඊට පස්සේ undulations කියන්නේ ඒක ඇතුලේ තියෙන්න පුළුවන් subsoil profile එක ඇතුලේ rock contours තියෙන්න පුළුවන්. ඒක අර flat land එකක් නොවෙන්න පුළුවන්. ඊට පස්සේ ඩ්‍රේනේජස් ඒක ඇතුලේ ඩ්‍රේනේජ් ලයින් තියෙන්න පුළුවන් ඒන්ෂන්ට් කාලේ ඉඳන් එන ඔය ඩක්ස් එහෙම තියෙන්න පුළුවන් ඊට පස්සේ ග්‍රවුන්ඩ් කන්ඩිෂන් ගත්තොත් එහෙම එක්ස්පැන්සිව් සොයිල් තියෙන්න පුළුවන් සබ්සිඩිව් කන්ඩිෂන්ස් තියෙන්න පුළුවන් කලූෂන් කලැප්ස් වෙන්න පුළුවන් සොයිල්ස් කන්ඩිෂන්ස් තියෙන්න පුළුවන් එතකොට ඔය හැම දෙයක්ම ටොපෝග්‍රෆි කියන එකට අයිති වෙනවා එතකොට මේ ඉම්පෝර්ටන්ට් ෆැක්ට්ස් ටික ඔය ෆැක්ටර්ස් ටික අනිවාර්යෙන්ම අපි කන්සිඩර් කරන්න ඕනේ සිලෙක්ෂන් ඔෆ් ලෑන්ඩ් යටතේ okay. The third one is subsoil condition. As I explained earlier in the number 2, subsoil condition is again a very vital. It's actually acting very vital role. So definitely you need to have a clear idea, clear understand about the subsoil condition. The one thing you can do to identify the subsoil condition is providing a boreholes. So using a borehole, only you can have a clear idea about the subsoil condition. what is the soil type, whether it is silt, whether it is clay, whether it is peat, or whatever the condition. Then you can, through those information, you can actually have idea about the bearing capacity of the soil. Normally, keep that in mind. The general norm is 200 kilopascal as the bearing capacity is the safest margin. 200 kilopascal. If your soil bearing capacity is compared to the low, that means the marginal value, which is 200 kilopascal, definitely you might have to do this ground improvement. Okay, so that is that. I'm just stopping with that level. Otherwise, I need to explain so many geotechnical parameters. Okay, that is that. Then the water bodies. Definitely, you need to have a water body. Otherwise, you can't actually live. You need to have waterways, water bodies, any that means consumable water areas. That means there will be some government water bodies. That means some, let's say, water board. They are providing the water, and some you can provide some tunnels, some sorry, tube wells and normal wells. Okay, some areas you can't actually have the wells. You don't have water. Your water table is very much low, so you can have the water easy. Even you have the water, it will drain out quickly. Some areas like Anuradhapura, Polonnaruwa, and some Monagagal areas, if you have the water, but definitely it's drain out. If you don't get in the rain continuously. Okay, that is those so many things you need to cover up. And the other hand, the water supply in one hand, the other hand is the other for the negative side, which is wetlands and marshy lands and coastline. In the coastline areas, definitely if you want to construct a house or any structure in the coastline, there will be some different strategies you need to adopt when you are doing the constructing. Wetlands and marshy lands. If you consider the marshy land, the peat soil, that the soil type, if you consider the peat soil, the peat soil itself, the soil bearing capacity is null. Okay, if you observe the peat soil, you can't do construction works there. Definitely, you need to remove the peat soil first, and you need to do the ground improvement using the good soil. Otherwise, you can't do any construction work on top of the marshy lands or wetlands. That is that. Keep that in mind. So water bodies, there are two ways. One is positive side, the other negative side. Okay. Number 5, vulnerability to hazards. Now I have explained all the way about this thing, so I'm not going to going through this thing. The number 6, performance of neighboring buildings. Again, I have explained this one. That means you need to understand the performance. That means for a, let's say you have a 5 to 10 story building nearby your land area. Now you are also going to construct a mid-rise building in your land. In your neighboring land, there is a building which is having 6 stories, let's say. And if you observe that particular building now, which is in the performance stage, that means it's already occupied by somebody. For example, that is a hotel. So people are there going there. Some wedding halls are there. So many performance are there. So what will happen if you observe if you observe any structural cracks or any structural deformations inside that building? Definitely, if you want to construct a neighboring, if you want to construct your house or any structure neighboring to that particular building, definitely you need to have a proper soil investigation. That means that issue might repeating to your structure also. Maybe there will be some expansive soil underneath that structure. So since your structure is neighboring to that one, definitely it will be inherent to your structure also. එතකොට ඔයාගේ ළඟ ආසන්නයේ තව බිල්ඩින් එකක් තියෙනවා නම් ඒ බිල්ඩින් එකේ ක්‍රැක්ස් හරි මොනවා හරි ඩිෆෝමේෂන්ස් තියෙනවා නම් අනිවාර්යෙන් ඒක ගැන අනිවාර්යෙන් අවබෝධයක් තියෙන්න ඕනේ. ඔයා මෙතන ඊළඟ ලෑන්ඩ් එකේ හදන්න කලින් ඔයාගේ බිල්ඩින් එක. එතකොට එයාගේ ලෑන්ඩ් එකේ තියෙන ස්ට්‍රක්චර් එකට ඉම්පැක්ට් එක වුණා නම් ඔයාගේකට අනිවාර්යෙන් ඒක වෙන්න පුළුවන්. එතකොට ඔන්න ඕවා තමයි සිලෙක්ෂන් ඔෆ් ලෑන්ඩ් එකේදී ඔයා ලෑන්ඩ් එකක් සිලෙක්ට් කරනවා නම් අනිවාර්යෙන්ම බලන්න ඕනේ ක්‍රයිටීරියාස්. Okay. Number 7, accessibility. Okay, if you have all the 1 to 6 criteria satisfactory, but if you don't have proper access to that particular land, what will happen? No usage. No usage. So there will be proper access roads, and also there should be some ground stability issues. Okay, there will not be ground stability issues, free of ground stability issues. That means you need to actually check period of time whether there will be some ground stability. That means ground subsidence conditions and the expansive soil conditions. You can actually get those information from the neighboring. You can ask from the neighboring people whether there is some kind of issues with the ground stability. Okay, so normally you need to omit this hill or terrain unless if your construction is related with the hotel type or villa type. Okay, some of the areas actually these hill terrain areas they are constructing purposely. Okay, in terms of this attracting the foreigners, guests. Okay, so that is that I have go through these 7 criterias when it comes for the selection of land. Okay, this is also very much important. If you want, just take a screenshot of this image. Okay, so these are the planning clearances and other approvals. Okay, this is actually I have clearly interpret. So these are the actually authorities you need to get the clear answers when you are planning to do a construction work. Definitely, if you want to select a land in hill areas, terrain areas, definitely you need to meet NBRO, National Building Research Organization, and you need to get approval for the planning construction activities. Okay, so in that approval, definitely you need to have a assessment for the landslide risk assessment. Okay, so that is that. Okay, then here I have mentioned the stage to obtain. That means when you need to obtain this approval. Okay, and the purpose of approval, and also the approving authority, and also what are the legal documents. Okay, all the things I have meant here. You can refer all these things. So I'm just telling you the what are the authorities: Urban Development Authority, and what are the others? Coast Conservation and Coastal Resource Management Department. If you want to purchase a land in coastal regions, definitely you need to go and meet Coast Conservation and Coastal Resources Management Department, CCRMD. Okay, so likewise there are so many authorities and issuing institutes you need to get the approvals. And not only that, after the planning phase also there are certain approvals you need to obtain from urban council, municipal council, and also from the Pradesh Sabha. Okay, and the most important document will be the certificate of conformity. Normally we are telling it as COC. The COC approvals definitely what that is the final approval you need to obtain before functioning the house or any structure. So you can actually see in this column, second column, stage to obtain. It's mentioned as after construction is completed and prior to occupying. Okay, okay. The next important fact is layout and orientation of hazard resilient house. Okay, now if your structure is very long, okay, let's say your structure is very lengthy, you can't actually do the construction. You can do the construction, but keep that in mind. We are recommend to do the shorter structures. If there will be deformation in build in this particular lengthy structure, the entire structure will be uh, subjected to that issue. Okay, so definitely you need to divide the structure to shorter structures. Okay, now here The second part is a plan the layout of internal spaces. Okay, as to fit into a simple structural system. Definitely, you don't need to have a complex structural systems. Just always going with simple structural systems. Okay, sometimes we are just going with these composite members when you are designing the slab and beams, composite members, and some post tension in pre-tension in members and all. But definitely we need to have adapt those adapt those systems. But actually we are recommend to use simple structural systems always. Number three, provide at least one small room in the interior of the house which can be structurally strengthened to serve as a safe refugee area. Normally, refugee area means, for example, if your structure is getting fired, that means if you ආගේ structure එක ඇතුලේ fire එකක් ආවා. Definitely you need to have a refugee area to go and safeguard yourself. So likewise, if your structure is a very big structure, definitely you need to have a small room inside the structure to safeguard yourself to avoid the fatals. That is that. Number four, should the house be constructed on varying ground elevations? Normally, without constructing flat land in various, if there is any elevation, if there is a varying ground elevations, okay. For example, if I draw like this, without constructing a house, wait, if you construct a house in this kind of land, now this is your house. Okay, now your house, let's say it's very lengthy. If there is a ground settlement means if there is an expansive soil or any water bodies inside, what will happen? Your entire structure will be subjected to this failure. For example, if your house is, let's say your house, if you want to construct in this area, you can't actually cut and fill and obtain the flat land. But considering the topography, you need to construct your house like this. Actually you can actually use this area as the entrance. Then you can have a second floor downside. Okay, lower ground floor. Then you can have another lower ground floor there, and you can provide some steps there. Likewise, if you, I'm just explaining you, if you can construct the house considering your topography without disturbing your existing topography, that is the safest way. That is the safest way. Okay, if there is any issue in this soil profile, in this soil stratum, your entire house will not be affected. Can you understand what I'm saying? Your entire house will be not affected if you construct like this. So that is the main advantage when you are constructing a house without disturbing its own topography. Okay, that is that. Okay, then the number five, decide the orientation of house with rectangular layout that is best suited to the location considering the following conditions, whichever is governing the safety. That means definitely you need to construct the house in rectangular conditions without instead of selecting any other shapes. Normally, in general, keep the shorter sides of the house facing the most critical wind direction. That means if your wind direction is coming like this, if your wind direction is like this, you need to face the shorter side of the house to that side. So that is why you need to always refer to these maps. Okay, wind hazards maps. Definitely you need to refer. Using those wind hazards maps, you can actually judge what is your wind side, uh, wind direction, and face your shorter side of your structure to that wind side. That is the safest way of constructing. Otherwise, what will happen? Definitely, you need, when you are constructing, let's say you don't have any option, definitely you need to face the length side to the wind direction. Then what will happen? In the design phase, you need to take that issue into account, and the design phase, when you are doing this parametric design, you need to use these parameters, and you need to strengthen the structure to safeguard or bear to lateral forces. Okay, that is that. Okay, number two, on hilly slopes, keep the longer sides of the house parallel to the natural contour of the slope. That means, for example, now this is a contour map. Okay, this is a contour map. Contour map means now you can actually feel what is the these are the levels of the existing ground level. These are the existing ground levels, and this terrain you can actually project. This is actually if you take the section along with this one. Now this is your terrain like this. Okay, so considering this topography, definitely in hill slopes, that means hill countries, that means mountain areas, if you want to construct a house, definitely your longer side should face parallel to the natural contours of the slopes. Okay. uh, okay. Now I'm just trying to explain these earth retaining structures. Okay. Okay, now this is the contour map. Okay, I have explained you what is this contour map and all. You can have a clear idea about what is your terrain, and if there is a mountain, what is the slope sides, and all the topography of the land area. You can actually have a clear idea after referring these contour maps. Okay, and also you can see these spot heights in this each location. Now this area is already divided into plots. You can see this spot heights. Okay, that is that. And now I'm going to explain you with this. This is actually map of Canterbury residences. This is actually a contour map. One part is a contour map. Now this area is contour map is there, but this area the contour map is not included here. Now I'm going to explaining through this one. I'm going to explain earth retaining structures through this entire scenario. Okay, now here already we have divided into plots. Okay, you can see the plots. Okay, now let's say I will again go into the beginning. That means I'm going to the zero level. The, just forget about this plotting. Just forget about this plotting. Okay, what you have to do is you have now select the land. Okay, now you have already selected the land. Now you have this kind of terrain. Okay, now this is this one. Just I'm just converting according to the contour map. This is your terrain. Okay, now this is your land. Now you are going to propose these green color roads. These are the access roads. Now your main road is there. This is your main road, and this is your land. And what you are doing is you are just developing. You are just schemating. That is how normally we are telling as schematic sketching. Schematic sketching. Okay, yeah, just schematically sketching the concept. This is actually conceptual design. Okay, අපි මේක නිකන් concept එකක් විදිහට develop කරනවා. දැන් මේ තමයි ඇත්තටම හරියට මතක තියාගන්න මේ තියෙන්නේ අපි දැන් land එකක් purchase කළා. ගත්ත ඔක්කොම criteria ටික consider කරලා අපි දැන් land එකක් purchase කරලා තියෙන්නේ. ඒ purchase කරපු land එකේ ඔයා දැන් plotting කරන්න යන්නේ. ඒ කියන්නේ ඔයා මේ ගෙවල් ටික place කරන්නේ කොහොමද? access roads එක මේවා කරන්නේ කොහොමද කියලා plot කරන්නයි යන්නේ. හරිද? එතකොට ඒකට ඔයාලට මෙන්න මේ ටෙරේන් එක යූස් කරන්න වෙනවා. මේ කොන්ටුවර් මැප් එක. දැන් කොන්ටුවර් මැප් එකෙන් ඔයාලට මේ ටෙරේන් එක අයිඩෙන්ටිෆයි කරගන්න පුළුවන්. ඊට පස්සේ මොකද කරන්නේ? දැන් ඔයා මුලින්ම ස්කීමැටික් ස්කෙච් එකක් ගහ ගන්නවා. දැන් ඔයා මෙහෙම ප්ලොට් කරනවා. දැන් මගේ ගෙවල් ටික මේ ලයින් එකේ මම ගෙවල් 22ක් හදනවා. ඊට පස්සේ මම මෙතන ඇක්සස් රෝඩ් එකක් දෙනවා. ඊට පස්සේ ආපහු ගෙවල් ටිකක් වෙනම හදනවා. ඊට පස්සේ ගෙවල් දෙක අපි වෙනම බවුන්ඩරි ලයින් එකකින් මෙන්න මෙහෙම බවුන්ඩරි ලයින් එකකින් ඩිවයිඩ් කරනවා. ඊට පස්සේ ආපහු පල්ලෙහෙන් ආපහු තව රෝඩ් එකක් දෙනවා. ඒ රෝඩ් එක දෙපැත්තට ෆේස් වෙන්න ගෙවල් ටික මෙහෙම අපි ෆේස් කරනවා. ඊට පස්සේ පල්ලෙහා ලයින් එකෙන් ආපහු බවුන්ඩරි ලයින් එකක් දෙනවා. ඔය විදිහට අපි ඔන්න ඔක ප්ලෑන් කරනවා. ඔකට තමයි කියන්නේ කන්සෙප්චුවල් ඩිසයිනින් කියලා. හරිද? දැන් මොකද කරන්නේ? හරි. දැන් ඔන්න ඕක අපි දාගන්නවා අපේ ටෙරේන් එකට. හරි. දැන් ඔන්න බලන්න දැන් රෝඩ් 1. රෝඩ් 1 කියන්නේ මොකද්ද? මෙන්න මේ ග්‍රීන් කලර් පළවෙනි එක. 1 2 3. Hurry. This is the road 1. Now this is road 1. Now this is road 2. Now this is road 3. Actually, you are selecting these roads considering this terrain. Keep that in mind. අපි මේක roads එක select කරන්නේ නැහැ ඕනෝට එපාවට. අපි select කරන්නේ මොකද්ද? අපි මේකේ බලනවා මේ terrain එකේ හැසිරීම මත තමයි road එක consider කරන්නේ. එහෙම නැතුව තමන්ට ඕන තැන් වලින් road දෙනවා කියලා හිතන්නේ නැහැ. මේක terrain එකේ highest point එකේ අපි road එකක් දෙනවා. ඊට පස්සේ මිඩල් පොයින්ට් එකේ තව රෝඩ් එකක් දෙනවා. ඊට පස්සේ ලෝවස්ට් පොයින්ට් එකේ තව රෝඩ් එකක් දෙනවා. කියලා හිතා ගන්නවා. හරිද? ඊට පස්සේ මොකද කරන්නේ? හරි. රෝඩ් 1 2 3 තුන fix. දැන් මොකද කරන්නේ? දැන් අපි කරන්නේ now what you are doing? Now you have finalized the roads. Okay, now this is road 1, road 2, road 3. Then what you are designing is now here you can see you in the road 1. Just forget about this area. Just forget about this area. Starting from this area. This one. Now you can see some houses here. Again, as I told you, this is a boundary line. Again, you can see some houses there, and again coming to the road 2. Now, again coming to here. Now just check. Now what you do? Now this is your boundary line. Again, this is a boundary line. Okay. Now this is your road. That means this is your fixed elevation. This is your fixed elevation. Considering the fixed elevation, that means the zero level. This is your temporary benchmark of zero level. You need to consider your formation level of this house considering the road 1. That means if you want to construct a structure there like this, you need to consider the zero level and formulate 1 feet above, minimum of 1 feet above, your structure will be constructed. Otherwise, what will happen? Your surface runoff will be go through your structure. Definitely, your structure should elevated by 1 feet. So that is why හැමතිස්සම මේක තමයි කියන්නේ අපේ සයිට් එකේ ඔයා formation level ගනිද්දී road එකට සාපේක්ෂව අඩියක් උස්සලා ගන්න කියලා. ඔයා මම හැමතිස්සම setting out බලන්න ආවත් කොහමද මේකේ formation level එක පෙන්වන්න කියලා අහන්නේ අයියේ. අහන්නේ මම බලනවා road එකකට සාපේක්ෂව ඔයා formation level එක හරියට තියාගෙන තියෙනවද කියලා. ඒකයි බලන්නේ. හරිද? හරි. එතකොට ඔයා මේ මෙතන මම පෙන්නලා තියෙනවා මේක පොඩි පේනවද දන්නේ නැහැ. මේක හොඳට බැලුවොත් පේනවා මම මෙතන 1 feet උස්සලා තියෙන්නේ. මේ fill එක. Hurry. Now this orange color area is a fill. Okay. Now here, this is the existing thing. Now this is your proposed thing. So what will happen? If you're going to construct a house here, definitely this area will be a fill. This red, blue color area. That means you need to fill the soil there. You need to fill the soil there. Then what will happen? Just again come into here. Now this area your house is there. Now the road 1 is there, and your formulated elevated 1 feet 1 feet elevated house is here. Okay. Now let's say for the simply identification purpose, I'm just marking this house. Let's get this 24th house. Okay. Now this is your 24 house. 24 house. Then this is your boundary line. Which is your boundary line? This is the boundary line. This boundary line. Okay? This boundary line. Then what will be your 59? What will be your 59? Your 59 will be here. It's in the lowered elevation. Then what will happen? If you want to fill this area, And if you want to retain this soil stratum, definitely you need to have this kind of structure. So that is normally we are calling as earth retaining structure. Understand? Okay. This is the now your this is your 29. This is your 59. This is your earth retaining structure, and this is your earth retaining height. Okay, this is your earth retaining height. Earth retaining height is not going to not counting from the foundation level. It's counting as the formation level of the lower elevation house. Okay, this is your formation level of the lower elevation house, and this is your formation level of the highest elevated house. So in between, the difference in between the height will be your retained height. Okay, so again, coming back now, what you have to do, then you need to cut this soil profile. Okay, otherwise you can't construct it. You need to cut this soil profile. So that is why some areas you need to fill and some areas you need to cut. Then come into the road 2. Now again road 2 is there. Then that means your house is again you can see 1 feet is elevated. Now again coming, I'm just going to explain here. Now 59 is there. Now road 2 is there. This is your 65. Now not like number 1, number 2 road, the two houses in opposite direction should be in the same elevation. For that one, definitely you need to have a fill in the right side of the road too. එතකොට ඔයාලට මේ ටික fill වෙන්න ඕනේ ආපහු. ඕකම ආපහු repeat වෙනවා මෙතනින් මෙහාට. මෙතන වාගේ boundary line එක වෙනවා. එතනින් එහාට again ඔගේ මෙතන වාගේ ආයෙ terrain එක cut කරන්න වෙනවා. මේ තියෙන වාගේ road 3 එක. පැහැදිලිද? ඔන්න ඕක තමයි අපි ඩිසයින් ෆේස් එකේ කරන්නේ. මේක තමයි අපි ප්ලෑනින් ෆේස් එකේ සහ ඩිසයින් ෆේස් එකේ ඔය කන්සෙප්චුවල් ඩිසයින් යද්දී අපි කරන දේවල් ටික තමයි මේ. එහෙම නැතුව මේවා ඉබෙන් පාත් වෙන්නේ නැහැ. ඒක මතක තියාගන්න. හරිද? ඉබෙන් පාත් වෙන්නේ නැහැ. මේවා මේ විදිහට ප්ලෑන් කරලා තමයි අපි ඔය ප්ලොට් එකක් හදාගන්නේ. මේ වගේ ලොකු ප්ලොට් එකක් හදාගන්නේ ඔය ටෙරේන් එක බේස් කරගෙන අපි ප්ලෑන් කරලා. ඒකට මේවා ඉනිෂියල් ස්ටේජ් එකේම අපි ප්ලෑන් කරනවා මේ ස්ථානවල රිටේනින් වෝල්ස් අපිට කන්ස්ට්‍රක්ට් කරන්න වෙනවා. එතකොට ඒක සමහර වෙලාවට අපි කොස්ට් එකක් යූස් කරනවා. මේ රෝඩ් මතනේ ඔක්කොම ඩිපෙන්ඩ් වෙන්නේ. ඔයා රෝඩ් එක මෙතන නැතුව වෙන තැනක සිලෙක්ට් කළා නම් අපි හිතමුකෝ දැන් මේ ස්ට්‍රේටා එකේ ඔයා රෝඩ් එක සිලෙක්ට් කළා කියලා මෙතන මොකද වෙන්නේ? ඔයාට මේ ඒරියා එක කට් කරන්න ෆිල් කරන්න වෙනවා ලොකු amount එකක්. ඊට පස්සේ මෙතනින් එහාට ගත්තත් ලොකු amount එකක් ආයේ කට් කරන්නත් වෙනවා. ඒ හින්දා ඔය හැම දෙයක්ම කොස්ට් එකත් අපි කන්සිඩර් කරලා තමයි මේ හැම එකක්ම සිලෙක්ට් කරන්නේ. පැහැදිලිද? හරි. ඔන්න අපි දැන් earth retaining structures ගැන ඉගෙන ගත්තා. දැන් earth retaining structure එක ඔන්න අතන දාලා තියෙනවා. Okay. Now I'm going to talk about in detail manner. Okay. Now earth retaining means you need to retain the earth profile without colliding or collusion. Okay. Now there are two things. One thing is if your soil profile is here. Now here I will explain through this one. Now this is your soil profile now. This is your soil profile. So this side there will be a earth pressure. Lateral earth pressure is undergo. Okay. This is a lateral earth pressure. Okay. Definitely you need to consider the active side as this side. This is your active side and this is your passive side. Okay, so if you consider in this structure, this is your active side. Okay, this is your active side and this is your passive side. That means active side means this profile is facing to the soil. Okay, this is soil. Okay, now this is existing ground level. That means your virgin soil. That means no any backfilling, no whatever the thing is done. this is මේක අපි කියනවා පිහිටි පොළොව කියලා. හරිද? පිහිටි පොළොවේ ඉඳන් තමයි හැමතිස්සෙම මේව කරගන්න ඕනේ. එතකොට පිහිටි පොළොවෙන් පල්ලෙහාට from the existing ground level, definitely you need to have a 2 feet minimum of embedment depth. So that is why we are telling as always අපි හැමතිස්සෙම කියන්නේ minimum embedment depth එක අඩි 2ක් ගන්න ඕනේ. මතක තියාගන්න අඩි 2 ගන්නේ හිතුන තැනක නෙමෙයි existing ground level එකේ. ඒ කියන්නේ virgin soil එකේ. අපි ගත්තොත් එහෙම cutting soil එකෙන් තමයි existing ground level define කරන්නේ. හරිද? එහෙම නැතුව backfill soil එකකින් අපිට කවදාක්වත් existing soil එකක් ගන්න බෑ. එහෙම ගන්නවා නම් මතක තියාගන්න. දැන් හිතන්නකෝ දැන් ඔයාට ඕන කියලා මේ ඒරියා එක backfill නේ දැන් මේ අපි කරලා තියෙන්නේ. දැන් මේ ඒරියා එක backfill. මතකද දැන් මෙතන නේ මේ ඒරියා එක fill. මේ fill කරපු ඒරියා එකේ ඔයාට මේ house එක construct කරන්න යනවා. මම කියන්නේ earth retention structures ගැන නෙමෙයි. හරිද? දැන් මේ house එක මේ number 14 කියන house එක 24 කියන house එක construct කරන්න යනවා. එතකොට ඔයා මේ fill එක උඩ මේක existing ground level එක කියලා හිතාගෙන මේක EGL කියලා හිතාගෙන construct කරන්න ගියොත් මොකද වෙන්නේ? මේ fill එක මේ original soil එකට වඩා එහෙම නැත්නම් මේ virgin soil එකට වඩා මේකේ strength එක මදි. ඒ කියන්නේ soil bearing capacity එක ගත්තා මේක මදි. එහෙමනම් ඔයා කරන්න ඕනේ මේක layer compaction කරන්න ඕනේ. You should do layer compaction. Layer compaction in the sense 150 millimeter layers you need to fill, you need to do the Proctor compaction test and the field density test, and you need to achieve the degree of compaction up to 98% for each layer. For each layer your degree of compaction should be 98%. If you satisfy with the 98%, only you can fill the above 150 layer. So likewise you need to fill up to the top level. Then just do that again FDT at the top level. If it is 98% only, you can assume this profile as existing ground level. Otherwise you can't assume this as an existing ground level. So that is why if you notice in the site clearly හොඳ අවධානයෙන් ඉන්න මිනිස්සෙක් නම් සයිට් එකේ ඒ හින්දා තමයි අපි 116 කොලම් ෂාෆ්ට් එක අච්චර උසකට ආවේ. ඇයි ඒ කොලම් ෂාෆ්ට් එක ගැහුවේ ඇයි? අපි බෑක්ෆිල් ගන්න කලින් තමයි මෙතන ෆවුන්ඩේෂන් එක එක්ස්කැවේට් කළේ. ඒතකොට යටනේ තියෙන ෆවුන්ඩේෂන් එක කොලම් ෂාෆ්ට් එක වාට ඒතකොට උඩට ලොකුවට පේනවා. හැබැයි ෆෝමේෂන් ලෙවල් එක බෑක්ෆිල් කළාට පස්සේ ලොකුවට පේන්නේ නැහැ. ඒක වැහෙලා යනවා. දැන් අපි මොකද කළේ? වටේම X6 ස්ට්‍රක්චර් මේ රිටේනින් වෝල් එක වටේම ගහලා තියෙන්නේ. දැන් ඔයාලා අද දකින්න ඇති එතන අපි බෑක්ෆිල් කරනවා ඒරියා එක. ඔන්න එතකොට ප්‍රශ්නයක් කරන්න. ඒක ප්‍රශ්නයක් වෙන්නේ නැහැ. මොකද අපේ ස්ට්‍රක්චර් එක කොලැප්ස් වෙන්නේ නැහැ. මොකද මිනිමම් embedment depth එක අපි දීලා තියෙන්නේ. හරිද? දැන් earth retention structures වලට අඩි 2 මිනිමම් කියලා ගත්තාට අපි ස්ට්‍රක්චර් එක කරද්දී house එකේ foundation එක අනිවාර්යෙන් අපි අඩි 3ක් ගන්නවා. ඒක මතක තියාගන්න. අපි earth retention structure එකේ වුණත් මේ retain wall එක ගත්තාත් retain wall එකේ columns යන තැන් වලට අපි අඩි 3ක මේ retain මේ embedment depth එකක් තියලා තමයි යන්නේ. රබල් එක තමයි අඩි 2කින් අපි foundation එක නවත්තගන්නේ. පැහැදිලිද? එතකොට දැන් මේකේ මම මේකේ longitudinal section එක ගත්තා. If you take this longitudinal section you can see the column locations. In these column locations you need to have, that means if you construct, now this is your existing ground level, this is your EGL. If your foundation is like this, your column is going like this. Okay, now this is 2 feet, this is 2 feet, and this will be 3 feet. Okay. Then when soil is to be retained in near vertical deep profiles, okay, that means this kind of vertical deep profiles will be retained කරනවා නම් soil එක, definitely you can have this kind of selections of retaining wall. What kind of selections? This kind of gravity retaining wall, reinforcement concrete wall, or embedded walls. Okay, and the other hand, just keep that in mind. You can see the weep holes. Now what is weep hole? Why we are providing these weep holes? Okay, there will be groundwater, so there will be induced water pressure from this active site, so you need to release the surcharge. So I'm not going to explain this technical terminology. I'm assuming in the university levels, campus levels, you are just touching with this terminology. If I going to explain one by one, there will be not enough time here. Okay, I'm just assuming that you all know about these things. You need to release the research charge. That means water pressure. So that is why we are just keeping these weep holes. Okay, not just the weep hole. We need to provide the metal packing. Why we are providing metal packing? You need to trap the mud and the soil. Otherwise, what will happen? Not just the water, it will flow with the mud. So that is why we have to provide the geotextile and the metal packing. Geotextile itself entrapping the mud, liquid mud. This metal packing entrapping the small particles. So that is the purpose of providing geotextile with metal packing. Okay, and also we need to keep these weep holes in staggered manner. Staggered manner means what? That means like this, not in just in a one line. It's like this, staggered. Okay, so that is that. Okay, moving on. So these are some stages. Now here you can see what I have explained earlier. Column is going downside again 1 feet from the foundation level, rubber foundation. So that is that. Okay, number four, the final phase, the design and construction phase. Okay, as I explained you earlier, so you need to have a clear idea about the subsoil condition. So these are the subsoil conditions and the related bearing capacities. Okay, now there are two types of soils: non-cohesive soil, which is sand or sandy. The other one is a cohesive soil, which is clay. Okay, normally the non-cohesive, that means the sandy, that means අපි sandy ගතිය වැඩි වෙන්න soil bearing capacity එක වැඩි වෙනවා. එතකොට අපි සාමාන්‍යයෙන් subsoil profile එකේ dense gravel or dense sand or gravel නම් තියෙන්නේ සාමාන්‍යයෙන් අපිට ඒක හිතන්න පුළුවන් just idea එකක් ගන්න පුළුවන් bearing capacity එක 250 to 300 තියනවා කියලා, which is very good value for the construction works. But if your soil profile is cohesive, that means there will be so many clay soil. That means your bearing capacity can be reduced up to 50, even 50. Okay, so I have shown you some images of this gravel and sandy soil. So if you go further down, you can see the peat soil. Peat also one type of clay, but peat soil or organic soil, definitely you can't do any construction on top of the peat soil. Keep that in mind. Definitely you need to remove the peat soil and you need to do proper ground improvement before doing the construction work. Okay, that is that. Now this is the foundation design parameters. Actually, this is the relation in between column loads, footing size, and safe bearing capacity and bearing pressure. Okay, so actually you can have a clear idea about these column loads. Now normally axial loads normally we can assume as the column loads. Okay, column loads එක එන්නේ අපි සාමාන්‍ය axial load එකක් එහෙම නැත්නම් point load එකක් විදිහට තමයි consider කරන්නේ design phase එකේ. So අපි නිකන් example එකක් ගත්තොත් එහෙම මේ column එකෙන් අපිට එනවා axial load එක 240 kN වගේ axial load එකක් එනවා නම් අපිට just පොඩි calculation එකෙන් ඔයාලට footing එක design කරන්න පුළුවන්. footing එකේ කොච්චර size එකකින්ද එන්නේ කියලා design කරන්න පුළුවන්. For example, for that one we have a separate diagram for that one. You need to have this kind of diagram depending of the column load. Okay, let's say now we have our column load is 240 kN. Let's say you are supported clay. That means ඔයාගේ soil profile එක මොකක්ද කියලා කියන්නේ column එකේ footing එක අපි place කරන soil එකේ profile එක මොකක්ද? අපිට ඒක soil investigation එකෙන් හොයාගන්න පුළුවන්. එහෙම නැත්නම් by looking at, for the geotechnical engineers, by looking at they can actually judge. For example, let's say the soil profile is stiff clay. Now where is the stiff clay? It is actually under 250. Okay, stiff clays, it's actually 100 to 150. Let's assume it is 200 kilonewton. Okay, it is 200 kilonewton. Then considering the chart, just what are the two arms? One is total column load, the other one is safe bearing capacity of bearing pressure. So you know all these two values. 240 kilonewton is the column load, and 200 kilonewton per meter squared is the your bearing capacity. This is your 240. This is your 200. So what will be your value? Just interpolate among these two values. So what will be your value in between these two parameters? That means the 100,000, sorry, 1000 into 1000, and the other one is 1200 into 1200. So safest value is, what will be the safest value? Say for the safest value, just consider the lowest bearing value. Don't go upward. Just for the safeguard. So safeguard based structure. Again අපි safeguard කරනවා කියන අපි තවත් හිතනවා මේකේ bearing capacity එක අඩු value එකක් තියෙන කියලා. ඒතකොට ඒක අපි safety එකට වැඩි තවත් හොඳයිනේ. අපි footing එකේ size එක තව strengthful එකක් එනවා. ඒතකොට අපි මේක 200න් උඩට නෙමෙයි තව 200න් පාතයි කියලා හිතලා අපි select කරගන්නවා මේ දම් පාට line එක. දම් පාට line එකේ මොකද්ද size එක? 1200 into 1200. අන්න එහෙම තමයි අපි කොලම් ෆුටින් එකේ size එක තෝරගන්නේ. ඉතින් මම මේ විනාඩි 2ක 3ක කාලෙකින් ඔයාලට මම මේ ඉගැන්නුවේ මොකද්ද කොහොමද මේ pad foundation footing එකක් decide කරන්න කියලා. ලොකු දෙයක් නෙමෙයි ඇත්තට මේ 240 කිලෝ නිව්ටන් එක හොයාගන්න එක මහ ලොකු දෙයක් නෙමෙයිනේ. මේ තියෙන point load එක. තියෙන self weight එක calculate කරගත්තා කොහොමද ඒකේ තියෙන අපි තුම roof structure ගන්නන් තියෙන roof structure එකෙන් එන point load එක calculate කරගත්තා. මේක ගන්න පුළුවන් ලේසියෙන්. ඊට පස්සේ මොකද්ද මේ 200 කිලෝ නිව්ටන් soil bearing capacity එක. soil bearing capacity එකේ අදාළ soil profile එක අනුව ඒක vary වෙනවා. stiff clay එකක් දැන් මෙයා මෙතන දීලා තියෙන stiff clay එකට අදාළ මේකෙන් table එකේ value එකක් අපි safest margin එකේ value එකක් select කරගත්තා. ඒකට අදාළව මේකේ graph එකෙන් point එක select කරගත්තා. ඒකේ අපි lowest bearing capacity එකට අදාළ වෙන graph line එක select කරගත්තා. ඒක තමයි ඔයා දෙන්න ඕනේ footing එකේ size එක විදියට. හරි? ඔන්න ඕකයි කතන්දරේ. හරි. This is for the column foundations. But for the wall foundation, what we'll do? But for the wall foundation, it's a different scenario. එතකොට මේක එකම පැරාමීටර් එක අපිට ගන්න වෙන්නේ මේ ෆවුන්ඩේෂන් එකේ width එක. හරිද? කොහොමත් ඔයා මේ minimum embedment depth එක කොහොමත් දෙන්න වෙනවා. අඩි 2 අනිවාර්යෙන් දෙන්න වෙනවා. මේක 450 එක වැරදි. ඒක 600 අනිවාර්යෙන් කොහොමත් දෙන්න වෙනවා. එතකොට ඔයා සිලෙක්ට් කරගන්න ඕනේ මේ වෝල් එකේ thickness එක අනුව ඔයාගේ යන මෙතන මේ thickness එක කොච්චරද කියලා. හරි. එතකොට සිමෙන්ට් බ්ලොක් එකක් නම් යන footing thickness එක මෙහෙම දාලා තියෙනවා. ඒකේ footing depth එක කොච්චරද කියලා දාලා තියෙනවා. 225 mm brick එකක් නම් යන්නේ ඒකට අදාළ footing depth එක කොච්චරද කියලා දාලා තියෙනවා. ওই විදිහට හැම දෙයක්ම වෙනම define කරලා තියෙනවා. හරි. හරි. Now this is actually plinth or tie beam. Plinth or tie beams means මේක නිකන් අපි ගත්තොත් එහෙම ෆවුන්ඩේෂන් එක උඩ තියෙන walls වල එන loading එක transfer කරන columns වල transfer කරන element එක. ඒ කියන්නේ අපි ගත්තොත් එහෙම first floor slab එකේ අපි beams and columns වලින් මොකද්ද කරන්නේ? slab and beams columns වලින් මොකද්ද කරන්නේ? slab එකේ තියෙන load එක beams වලට transfer කරනවා. beams වලින් තියෙන load එක අපි column එකට transfer කරනවා. column එකෙන් foundation එකට transfer කරනවානේ. එතකොට ඒකම ground floor එකට apply කරොත් එහෙනම් මොකද්ද මේ වෙන්නේ? ground floor එකේ තියෙන wall වල load එක tie beam වලට apply කරනවා. නිකන් අපි first floor එකේ beam වලට කරා වගේ. ඒක ගිහිල්ලා foundation එකට tie beam වලින් columns වලින් transfer කරනවා. ඒක තමයි මේ කරන්නේ. Hurry. Okay. This now I am just explaining about the ground supporter slab. Okay. Now this ground supporter slab here. Now I just explained earlier if the area. Now this is the road. Now this is your stratum soil profile. Now this is your retaining wall. Now then what you have to do? You need to fill this area. No? This is your fill. Okay, then you are doing this backfilling. Okay, now you are doing this backfilling, layer compaction, and again this top level you are just checking the bearing field density test, and you are checking the degree of compaction whether it is okay with the 98%. Okay, then you can assume this one as the compacted soil. But even though you are assuming that as compacted soil, if you are constructing the ground supported slab, ground supported means your slab is supporting on the ground condition. If there is a backfilled soil there, if there is a backfilled soil, definitely you need to have a reinforced ground supporter slab. Okay, then coming to the superstructure. Now I have completed substructure. Coming to the superstructure. Now columns, upper floor beams, and roof beams. Though all these are the elements. Normally, these are the general norms. Keep that in mind. If anybody asks, just these are the general norms. But columns shall be placed at least at each corner of the house, and the space in between columns shall not exceed 5 meters center to center. Okay, and few important facts here. Now these lintel schedules and all I'm not going to explain with the time being, and just keep that in mind. I'm just explaining this very important detail which so normally we are providing the aluminum outer frames. Aluminum outer frame these days we are just fixing in the window areas. Definitely you need to have a proper waterproofing. Otherwise what will happen after 10 to 15 years, this might happen after 10 to 15 years, water is coming through this aluminum outer frame. If your structure is not like this, if your window reveal is not like this, definitely what the water will come inside. So you can actually take a snapshot here. So this is the correct procedure in the on top of the sill beam, okay, for the outer frames. So that is that. So that 9 meter square thing I have explained you earlier, so I'm not going to explain you again repeating. So this is for the unsupported laterally supported walls. 9 meter square definitely you need to provide. You can't exceed the 9 meter square. Without exceeding, you can provide stiffener beams and stiffener columns. Okay, that is that. And there are some type of roofs. One is pitched roof and the other one is flat roof. You can see this pitch roof. Pitch roof අපි pitch roof එකක් කියන්නේ මෙන්න මේකට. roof එකේ pitch එක කියලා කියන්නේ මෙන්න මේ angle එක. හරිද? මෙන්න මේක තමයි angle එක. roof එකේ pitch එක කියන්නේ මේ angle එකට. ෆ්ලට් ස්ලැබ් එකක් කියන්නේ ෆ්ලට් රූෆ් එකක් කියන්නේ අපි සාමාන්‍යයෙන් අපි රූෆ් එකක්. ඒ කියන්නේ අපි end point එකක් විදිහට යූස් කරනවා නම් කොන්ක්‍රීට් ස්ලැබ් එකක්. ඒක අපි ෆ්ලට් රූෆ් එකක් කියලා විදිහට යූස් කරනවා. කියනවා. එතන pitch roof and flat roof එකේ difference එක තමයි මේක. Okay, now I'm just rapidly go with the roof. Okay, now this is a pitch roof. Normally we are just constructing the pitch roofs in the villas also, as well as the residences. We have done the pitch roof. Normally this pitch roof is exposed rafter roof. Okay, මේක අපි කියන්නේ exposed rafter roof එකක් කියලා. Exposed rafters කියන්නේ අතන මේ තියෙන්නේ rafters. මේවා තමයි rafters. මේකට අපි කියනවා ridge board එක කියලා. This is ridge board and this is your wall plate. So that is why in the first few slides I have mentioned your wall plate should be fixed into the existing walls using M16 anchor bolt. Okay, your wall plate should be fixed to the existing wall using M16 anchor bolts. So this is your wall plate and this is your rafters. Now here you can see the rafter and here you can see the other side, opposite side. This is your purlin. Purlin we are using as 2x2s. අඟල් දෙකේ ලෑලි යූස් කරනවා අපි පර්ලින් විදියට. දැන් ඔයාලට ඒක හොඳටම බලන්න පුළුවන් මේ වම් පැත්ත කෙළවරේ තියෙන ෆොටෝ එකෙන්. You can see this is the rafter and here you can see the eye panels here. This is the eye panel and what is this? This is the heat proof foil. Why we are using heat proof foil? To avoid the heat intrusion into the house. In order to avoid the heat intrusion into the house, we have provided the heat insulation boards. අතුල නැත්නම් රත් වෙනවා වැඩි. ගෙවල් මේ වහලවල් කොච්චර උණුසුම වුණත් වැඩක් නැහැ. heat proof foil එක දාන්න නැත්නම් අතුල රත් වෙනවා වැඩි. එහෙනම් අනිවාර්යෙන් මේක දාන්න ඕන. මේ තියෙන these are the purlins. Okay, these are the purlins. On top of the purlins, you can place the zinc alum roofing sheet. Okay, so that is that of the this is all about exposed rafter roofing, and also we can tell it as pitch roof. Okay, now this is the most important thing when it comes for the roofing. Okay, now there will be some water leakages if you are not properly provide the flashings to the roof. For example, let's say now this is the wall. This wall is going to the downside. Okay, this is actually water tank slab. This is the water tank. Water tank is not placed inside, but this is a water slab. Here, this is a water tank wall. If what will happen if your roofing sheet is like this without this roof flashing? The flashing means we are just using zinc aluminum roofing sheet. Zinc aluminum sheet is this ash color sheet is the zinc aluminum sheet flashing. If you avoid this flashing, what will happen? Your surface water will be going through this wall inside. So what will happen with the time goes on, you can see uh, green color patches, algae growth in the walls. So in order to avoid that one, definitely in the right side corner, see the image. You need to provide the flashing. This blue color thing is the flashing. Your flashing should be embedded to the wall like this in this manner. Okay, then in this joint definitely you need to have a UV resistant sealant. Okay, on top of the sealant you need to have application of zinc proof. Zinc proof is a waterproofing agent. If you do like that only, your structure will be safeguard for more than 10 years. Otherwise, what will happen after 5 or for 6 years, there will be definitely a algae growth. Okay, so that is the importance of the flashing. Okay, so these are the impacts. If your flashing installation is not correctly done, there will be some wet patches like this. Okay, these are some wet patches in the walls. And if your structure if there is two different structures here, this is A and this is B, and this is your blind wall. If this blind wall is not properly covered, definitely water will go through this wall and will occur this kind of patches. And the other issue is if you are not properly provide the silicon along with this flashings, what will happen if you are not using the UV resistant silicon? Your silicon will be teared off with the time. Okay, so again the water might intrusion like this. So these are the main things in terms of water leakages. Okay, so other things actually internal plastering and all, I think you know so many things actually. So what are the areas you need to provide these gauges, measures, and what is the your plaster thickness as and all. What is the procedures and measures to avoid the shrinkage cracks on the plaster? You need to wet the plaster before and after. So I'm not going to explain one by one all these things. The external also like that. And the waterproofing also, I think not much things actually. You can I have provided the guidelines for each and everything for the waterproofing. That is that actually these are normally very straightforward things. I think not much things to cover up. For the tiling also, I have given a separate guideline for that one. Just you can go through that one. That is that actually. Then this is the situation now. Okay, now we have completed the residencies project as you can see in this image. Now we have moved to the villas site. Okay, now we are doing the construction of villas, and actually that is that. Okay, so we are in the level of completion of the villas. Now we are rapidly doing the construction works. Hopefully you can actively engage in positive manner.